A warm welcome, ladies and gentlemen, to yet another webinar in the Citrix Study Technical Webinar Series. We have a very interesting topic at hand today and a very special guest, NVIDIA. So the topic is powering hybrid work. I'm sure it's pretty timely for all of you. And obviously, you'll get to hear some great things about what we are doing together with NVIDIA, specifically on the HDX side. Before we go into the webinar, a few housekeeping details. The webinar is getting recorded, and we'll share the recording with you within 24 hours after the webinar. There is a formal Q&A session at the end of the webinar, but in case you do have questions while our speakers are talking through their presentations, please feel free to type those in the Q&A panel. We'll try to answer those questions on the chat, and if they're relevant to the whole audience, we'll take them at the end of the session. With that, let me bring on our speakers for the day. Let me first bring on Mohammed, my good colleague from Citrix. Mohammed, you want to tell the audience who you are and what you do at Citrix?
Sure, thank you, Rubel. Hi everyone, I'm Mohammed. I'm a developer within the HDX team here at Citrix, and I'm super interested in everything to do with graphics and performance.
Awesome, thank you so much, Mohammed. And our guest of the day from NVIDIA, Lee Bishen, over to you.
Hi everyone, glad you could come on this webinar, and it's great to be back, by the way, presenting for Citrix again. And yeah, so I'm a solution architect. I work for NVIDIA, and my main area of specialization is GPU accelerated virtual desktops. So you've come to the right place if you want to hear about that today.
Awesome, thanks so much, Lee. If you could help me move to the next slide, I want to take a quick minute to talk about what Citrix Study is. Some of you guys may have attended our earlier webinars, so you know that Citrix Study is basically the first source where you can evaluate third-party purchasing decisions. So in case you have the Citrix stack running in your infrastructure, if you do decide to deploy third-party technologies like NVIDIA on top, this is the place to go. You can find out all the compatible technologies and solutions available there. There's a quick URL mentioned at the bottom of the slide. Please feel free to look at what the solutions available there. And there's also a small incentive, if you can move to next slide, please, for the attendees today. So every 10th attendee on this webinar will receive an Amazon Echo Dot smart speaker device. Unfortunately, we can only ship this within US and Canada for logistics reasons, but stay till the end of the webinar to find out how you can claim that. With that, and without further ado, let me hand it over to Lee to walk you into the webinar.
Sure, Rubel, thanks very much. Thanks very much. So we've got a great agenda for you today. We're going to cover a whole number of things. We're going to talk initially about why do remote workers need a GPU. Okay, there's been a lot of stuff happening with remote work in the last couple of years, clearly, and we want to make sure that those users get the best experience. Also, in parallel with GPU acceleration, Citrix has been moving their HDX stack forward and evolving it even further to give you better quality. So Mohammed is going to be here to talk to us in depth about that. And we're going to try and keep it quite techy as well, which I know that's how you guys like it. After that, I'm going to be sharing some of the experience I have in tuning and setting up architectures around GPU accelerated virtual desktops for office workers, but also for graphics professionals as well. We'll talk about some of the do's and don'ts there. And then finally, we're going to finish off by talking about which GPU you need to have for each individual workload and which is the right license type for those individual users. Another thing to point out, we're going to be throwing a bunch of URLs at you down the bottom of all of the slides. Don't worry about that. There's actually a handout in this webinar. If you look at the control panel there under handouts, and it's got all of the links that we use today in that, and it's called the Useful Links PDF. Also, the whole slide deck is available as a PDF as well, should you want it for future reference. Okay, so let's get going. So why do remote workers need a GPU? Well, what's been happening for the last 2 and 3 years? Well, people have been trying to work from home, and how have they managed to do that? Well, thank you very much, by the way, because a lot of you actually bought GPU-enabled laptops and put them on users' desks at home. So the whole laptop thing has exploded over the last 2 to 3 years with people working from home. That's one way of doing it, and of course that's great for the laptop GPU side of things. But it brings with it a whole load of issues. Data is now less secure because it's sitting on a laptop at home. If users are collaborating on different technologies, different projects, they're finding they're having to replicate all of that data round to all of their individual homes and work on it separately. So there's no central point of data management in there. And also that there is a GPU in that endpoint, and whether or not that laptop itself is doing video conferencing, whether you're doing video playback, training, that sort of thing, or even just the general Windows operating system itself, and Office based applications, web-based applications, all that sort of thing, you will find that all of those really enjoy having a GPU in that virtual desktop. Now, here's the problem. People are now looking at this and saying, look, we tried the best we could for the last 2 years. Now, I was in the BBC headquarters up in London at New Broadcasting House a couple of months ago, and there was a whole bank of PCs there with notices on the front saying, please do not turn this PC off, accessing remotely. Okay, so people were doing the old access remotely thing down to a physical PC. The reality is people are saying, look, we want to do this properly. We want data to be centralized. We want it to be accessible from multiple places, multiple users. We want it to be secure, and we want to have a nice, easily managed infrastructure rather than just firing out thousands of laptops. And they're coming to us to say, how can we make that performance the best? Now, without a GPU, which is the natural state of a VDI desktop, you're going to find that all of that extra processing around video conferencing, video-based content, and just general 3D and graphics is going to fall to the CPU in the server. And this is going to have a problem, right? Because it's going to affect your scalability of your server. You can't get as many users on that server. Performance isn't as great as if you had that GPU assistance that the applications and operating systems are designed to expect. Okay, wouldn't it be great if you could put GPUs into your data center? Well, guess what? That's exactly what we've done with virtual GPU. The way we've done that is your server itself, your physical hardware, has a certified GPU installed on it. What we next do is we take the hypervisor and install a little management component into there called the GPU manager. What that will do is it will time slice the GPU up between multiple users. Okay, so every user will get the whole of that GPU for their own time slice. So it's all of the GPU for some of the time. Okay. On top of that, we have our virtual desktops, which have the application sets that the users are loading, whether they're office workers or professional graphics users. And within that, we also have an NVIDIA graphics driver. So as far as the applications are concerned, they're just talking to a standard NVIDIA card in there. The applications don't know that under the covers, this stuff is being time sliced. Okay? And this works really, really well. The only thing that isn't in this diagram is the license server. So there is a license server that when a workstation turns on, it will go to the license server and check out an NVIDIA virtual GPU license as well. Okay? So that's something that you also need to have in your infrastructure. We actually have a cloud-based version called the CLS now of our license server, so you don't even need to have that infrastructure there if you don't want it to. So that's the architecture of a virtual GPU-enabled virtual desktop. Now, alongside that, Citrix has been around. I remember having a 25-year T-shirt, and that was about 5 or 6 years ago. So it's well over 30 years now. That Citrix have been doing virtual desktops of some type for, and they've always led and they've always been ahead on the speed and the functionality within the HDX protocol. And with virtual apps and desktops 2112, what NVIDIA and Citrix have done together is actually optimize that even further. Okay, so that is why Mohammed Dawood nearly got it right. Nearly got it right, Mohammed.
Yeah, you got it right, Lee.
is here to talk about. So what I'd like to do now is bring on Mohammed, because Mohammed has done a great blog article talking about some of the optimizations that him and his team have made to the HDX protocol in the last 3 or 4 months. So Mohammed, what changes did you make? What changed in the last couple of releases of virtual apps and desktops, and why did you do that? These changes, and what's really been the outcome of those changes?
Yeah, thanks, Lee. So we had heard from customers and some internal users of the product that performance was not really up to expectations, especially when we compared ourselves with some competitor products. So we decided to take a fresh look at the way we talk to the GPU and eliminate any bottlenecks. Operations that we once thought were trivial for the GPU actually turned out to be quite costly. So we optimized frame capture and encoding, and what we did was to take advantage of the latest DirectX and NVIDIA APIs. And we did a lot of experiments around what works best. And our goal here was to reduce the Citrix graphics process GPU footprint so that other apps running get a bigger slice. And not only did we manage to do this, we also made some significant improvements to CPU usage as well.
So that's great, and I've read through the article a number of times, and I always pull out something new every time I read it. So thanks very much for doing that. It's great. At the moment, it kind of looks like you've done the HDX stuff. How does it relate to having a GPU underneath that virtual desktop? How do these optimizations work in tandem with a GPU?
So most of the changes we made were not NVIDIA specific, believe it or not. So we expected to see improvements across the board with other GPU vendors as well. What we actually found was that NVIDIA cards benefited the most, and that indicated to us that NVIDIA's support for some of these advanced GPU concepts were clearly more optimized, which was great to see. And we tested with the latest NVIDIA cards. You kindly gave us an A40 and an A16. And we saw some fantastic improvements beyond our expectations, actually. And now we're seeing up to 120 frames per second at 4K. So really, what we are doing is taking advantage of the latest GPU tech by using these newer APIs, and we're seeing really great performance as a result.
Awesome. Really good to hear, because people are used to having that physical workstation or physical laptop, especially at the top end where you've got engineers, designers, graphics artists, that sort of thing. So some of the use cases around this, who can really benefit from all of these optimizations between HDX and a GPU?
Well, actually, the great thing about these improvements is that all workloads are improved. So any app that uses a GPU, be it for computation or for rendering, those apps will not be impacted as much if the Citrix graphics process is also doing some work. So one thing we monitor is session interactivity and how well the session is responding to user input. And what we thought was, what better way to do this than to try and play the latest platformer? And that we did in the name of testing, of course. And the results were amazingly good. As I said, we were getting up to 120 FPS at 4K with no perceptible latency. It's like we were playing the game locally. So we thought if we could conquer the gaming workload, by default, every other workload, for example, the designers, the artists, even in the medical industry, all of those workloads would benefit.
Yeah, in fact, I am dealing with all of those areas. So I deal with vGPU and virtual desktops across all of those verticals. I speak to people that are developing solutions for radiographers, radiologists, so that they can actually remotely work. One NHS company I'm working with in London has all their radiographers spread around the country. Even before COVID hit, they couldn't afford to live in London, but they still wanted to provide skilled kind of analysis of radiography. So what they do is they actually use VDI to do that, and NVIDIA GPUs underneath. We speak to people. We've got TV companies that use the Adobe suite, for instance, a lot. We put a POC in for one TV company, and we didn't realize until it was too late. It was about a month later in this POC, we realized it actually gone into production, and there were people doing live editing on live TV using the Adobe suite, and it was only supposed to be a POC. So that's how quickly it caught on there. Obviously, we've got engineering, AEC companies doing that. And I think also most people that do this will really only need 60 frames a second to run. But having that additional ability to go up to even 120 frames a second can actually leave some higher end workloads as well, can't it, Mohammed?
Absolutely, yeah. And the way we thought about it was, well, yes, you're right in saying that 60 is probably most that anyone would ever want. But we are starting to see workloads that need 90 frames per second. For example, virtual reality is a great example here, where if we cannot sustain a throughput of 90 frames per second, the user starts to feel sick and gets motion sickness. So for us,
Yeah.
the fact that we can hit 120 and even higher in some cases allows us the headroom to well, certainly it gives the headroom to other applications running in the session to basically not restrict them in their rendering performance.
And of course, all this filters all the way right down to your standard office worker that maybe is doing some video conferencing, maybe is doing some video-based training, watches the BBC News at lunchtime while he's having his sandwich, that kind of thing, right?
Yeah, definitely. So any offloading we do here to the GPU will benefit responsiveness and even higher quality graphics. So this is something which is not pointed out very often, but we've noticed that NVIDIA's video encoder, also known as NVIDIA, seems to do a better job at maintaining higher quality graphics in low bandwidth situations, and that's in comparison to our software video encoder. So not only are we offloading tasks to the GPU to reduce CPU usage, we are also getting better quality graphics as a result.
Yeah, and we also find that latency reduces as well, because all of the graphics processing is kept on the GPU instead of having to go out to memory or to go out to CPU. But we actually find that the latency, the snappiness of the user's desktop is actually a lot better, as well as being more smooth. So,
yes, yeah.
So thanks, Mohammed. We'll be going back to you in a few seconds. I just wanted to point out, really, I work with a lot of projects, and these projects have a whole pipeline of things, and quite often people haven't necessarily thought about the overall pipeline in graphics and what needs to be done to optimize all of that. They'll just have this assumption that they can just put a GPU into the server and they're going to be off to the races. Everything is going to be absolute perfect experience, and that can help, but it's far from being the only thing you need to consider. So I just want to spend a few minutes just to talk to you through the various components in that pipeline and why they're all important. So first of all, we start off with a GPU. Okay, you make a very broad brush idea of which GPU you need and get one for your POC. If it's low end, it's going to be A16. If it's high end, it's going to be A40. We'll talk about that in a few seconds. You put it in some certified hardware. All of the major vendors have certifications, and the link we've given you on the PDF will take you to our hardware compatibility list. And that's great. You've got a GPU in there, and you can then install the GPU manager on top. What's also important, though, is what the density is. What are your aspirations around density? Are you wanting to get 240 users on a server, or are you wanting to get, maybe 64 or 32 users, high-end users on there? What is that going to be? That will lead into the discussion around what applications you have. So it's always about what is the application. It's literally no point in having a turbocharger in a car if you haven't got anything to accelerate. Okay, and it's the same with the GPU. GPU is a turbocharger, so unless applications and operating systems are using the GPU and have been written to use a GPU, there's little benefit to actually having, or lower benefit to having a GPU in there. So you really need to know what the workload is around your GPU. Also, what's the density? So we can slice this up maybe 16, 32 ways, or we can just have a one-to-one relationship between a user and a GPU. So somewhere in between is probably where you want to do that. And it's only by testing with a POC can you actually just start off with a default profile and then move it up if its performance isn't good enough and give them a bigger profile, or move it down if you want a bit more density. But you can only really make those assumptions and decisions based on real world data. On top of that, of course, it's great having nicely rendered content in the data center, but that content needs to make its way down to the endpoint, which is where the HDX protocol comes in. This is really important, and how you tune this part of the pipeline can make or break, okay, between having a great performance at the end user's desk and having a rubbish performance, okay? So think about the policies. A lot of the policies are set out with the default standard office worker in mind. They might not be the same policies that you want to implement with a high performance graphical user. Okay. And then, of course, don't forget the endpoint hardware. The endpoint is just as important as having a GPU down at the other end. I've been into customers where they've put the fastest GPU in their server. They've got a massively great, 100 or 10 gigabit network onto a thin client, and they've got 2 4K monitors. And when they're moving their box across the screen, it's like it's on an elastic band going back and forth. There's so much latency there, and they're like, what's going on? We've got the best GPU, we've got the best network, the best server. It's still slow. What's going on? The reality was their endpoint was 7 years old. It was an old Dell thin client, and it just wasn't capable of decoding all of the traffic that was being thrown down to it from the virtual desktop. So that, in that particular case, was what was causing latency. So be really careful that your endpoint hardware is sufficient. Also think about the number of screens you're going to use at the endpoint and what the resolution of them are. Because the more screens you have and the more resolution, the more pixels need to be held in the GPU and the larger the frame buffer profile needs to be. So all of that makes a lot of impact. If you test the GPU solution with a single monitor, then when you go into production, it's a dual monitor, or lo and behold, someone comes along with a 4K monitor and bungs that on their endpoint. And I've had that happen many times before as well. Suddenly, the GPU frame buffer goes through the roof and performance starts to get bad. So think about that endpoint. Now, what we're going to do next is we're going to talk about that last mile, if you like, the bit between the VDA and the endpoint. We're going to be talking about the protocol now. So what we'll do is we'll bring Mohammed back and maybe talk a little bit more in detail about the HDX policies themselves. So Mohammed, are you with us?
I am, yes.
Excellent, excellent. So first thing I want to talk about is frames per second. Now, we talked about FPS and the way we could get that up to 120 if need be. The default cap for an NVIDIA enabled desktop is 60. Okay, so we have a frame rate limiter there at 60. You can turn the frame rate limiter off in a couple of different ways, either with a switch on the metadata of the VM, or you can do it by changing the scheduler as well inside the GPU. But what is this target frame rate setting that we have as an HDX policy, and why is it important?
Yeah, good question, Lee. So the default setting is 30 frames per second, and this is generally acceptable in most use cases. For more demanding workloads, for example, in the media and entertainment industry, a target of 60 is probably more desirable, but do expect bandwidth and GPU usage to increase as a result. Higher than 60, as I was saying earlier, is rarely, if at all, needed. But one use case we've found is virtual reality, where at least 90 is required to not induce motion sickness. So there is a magic registry key I can share that allows us to deliver up to 120 for those that really want to explore the limits. But as I said, 60 is probably the most that's ever going to be needed, certainly for the foreseeable future in production. But yeah, as I said, do expect your bandwidth and resource usage to increase.
Okay, and I think we'll talk about licenses in a minute, but we've got 2 licenses. One is for office worker and one is for professional graphics artists. The office worker one limits frames to 45 frames a second, because the idea is that an office worker really doesn't need more than 45 frames. So that would be the default frame rate limit we would allocate there. And with the virtual workstation license, we offer 60 frames per second in there as well. If you want to go higher than that, you can do, but you either turn off the frame rate limiter You'll also have to use that in conjunction with Mohammed's secret switch to turn off or to increase 60 frames a second. The other way of doing it is to change to one of the equal share or fixed share scheduler on the GPU as well.
Yeah, and I should add that we are looking to expose or increase the policy value from a maximum of 60 to 120 as well in an upcoming release. Yeah.
Brilliant. Okay. So frame rates, we've got a nice frame rate now, so our desktop is nice and smooth. But obviously there's two main ways of taking those screens in the data center and moving them down to the endpoint. You can send pictures, okay, RLE, JPEGs, bitmaps, whatever. Okay, you can send pictures, or you can send a video stream. So H.264, H.265. Which is the right type of remoting delivery for each individual use case, Mohammed?
Yeah, so I get asked this question a lot, as you can probably imagine. So let me explain the differences first. So ThinWire is our default graphics remoting technology, and this involves very deep frame-by-frame analysis. And as you said, updates here are issued to the client as a series of bitmaps, and we compress these bitmaps where necessary. So we can also detect video or animation and encode just those regions with a video codec like H.264. And you may have heard this referred to as selective H.264 or actively changing regions. And taking that further, if a GPU is present, we can use it to encode those video regions. And if not, we'll use our default software video encoder. So that's one way of delivering a desktop to a user. The other way is to use the video codec, for example, H.264, for the entire screen. And what this does is it bypasses most of the ThinWire analysis that I mentioned previously. Here, we basically treat the entire screen as a video stream. And just like selective H.264, if a GPU is present, we can encode this stream in hardware. So both have their advantages and disadvantages. So ThinWire is optimized for bandwidth and CPU and can deliver a really compelling experience in a variety of scenarios, especially when resources are constrained. But for more intensive workloads, it may not be able to deliver the immediate interactivity and response a user might expect. For example, a steady 60 FPS at 4K. And this is primarily because of the extra image analysis that's going on and the GPU to CPU conversions we're doing behind the scenes. So here, using a full screen video codec is great for high-res interactive workloads, but this comes at a cost, mainly bandwidth and even image quality. And as you were alluding to earlier, the client has to be able to handle the high FPS. So we always recommend a decent GPU at the endpoint as well.
Absolutely, and of course there are other policies as well. So, for instance, you've got the build to lossless policy as well, Mohammed, haven't you?
Yes, we do. So, with all of that said, a good compromise is the build to lossless policy, and this is trying to give. This is basically a special configuration of ThinWire under the covers. And it's turning off a lot of this image analysis to try and improve the responsiveness. The idea here is to give really good interactivity when you're moving things around by using the full screen video codec. And once you've stopped moving things around, we gradually build to a pixel perfect image. So the idea, we're trying to give the best of both worlds here. Unfortunately, we cannot yet auto detect the workload and switch into build to lossless automatically. It is a policy setting, so you have to know up front that your users are going to want build to lossless. But what I can also share with you today is that we've got two main improvements coming up, specifically to do with build to lossless. So a lot of users don't like the way we build to lossless, which is typically starts in the top left corner of the screen. And it's especially noticeable in low bandwidth cases. So now we're going to start building to lossless from where the mouse cursor is. And we've prototyped this, and it actually looks really good, and it feels a lot more natural. So that's going to be in an upcoming release. And we're also going to look at giving near full screen video codec performance when things are moving. So today we're not quite there due to some architectural limitations, but we've seen a way to hopefully give the best of both worlds. So give great performance, the same performance you get with full screen H.264, give that performance with build to lossless whilst you're moving things around, and then it will build to pixel perfect like it does today, except that it will start around where the mouse cursor is. So yeah, stay tuned. I'll probably blog closer to the time for when these two improvements are going to be released.
That's really interesting. It actually reminds me a little bit of something that we've done at NVIDIA with VR, where we build to perfect quality where the user's looking in the VR goggles, and everything around it is slightly blurred as they're moving, which is just the way that your own eyes are, right? It
Yeah,
focuses
so
on
I have actually, just funny you should mention that, Lee. I prototyped this a number of years ago. So I did a build to lossless using an eye tracking device, and where you looked was where it built to lossless. And that's taking it a step further from the mouse cursor. The mouse cursor is a reasonably good indication of what the user is doing and where the user is looking at. It's not perfect, but it's better than what we do today. But yes, the next step would be to take advantage of some of these eye tracking technologies and build that in. And at the time I was using a third-party device, but some of this technology is now being built into monitors, so that's perfect for this sort of graphics mode. Yeah.
Yeah, so on the quality settings, so we're talking about things like build to lossless, what codec we use, what frames per second. What about the quality settings? What do you recommend that people use there?
Well, as you know, build to lossless is one of those quality settings. So hopefully you know now when you need build to lossless. Always lossless is really aimed at the medical sector, where you need to know that the image is always lossless, pixel perfect. The last thing you want is to misdiagnose a tumor, for example, due to a fuzzy JPEG, and that's really the worst case scenario. So always lossless will not give you a great frame rate. It will use a lot of bandwidth because it's lossless imagery, and that's really expensive, even though we compress it as well as we can. But it will guarantee a pixel perfect image 100% of the time, even when you're moving things around. And then we have the other three visual quality settings, which is low, medium, and high. Medium is the default and really should satisfy 90% of the use cases out there. It sets a pretty high JPEG quality. High visual quality just slightly increases that JPEG quality to about 95 out of 100. Medium is around 85 to 90 out of 100. It floats depending on your bandwidth and latency. And low is really aimed at the very low bandwidth connections, where we really drop the JPEG quality, and we also enable some other optimizations within ThinWire to try and help interactivity.
Now, I know we were going to talk about chroma subsampling, but let's shelve that and talk about that in a second, because I've actually got a demonstration in a minute of chroma subsampling. So let's just do that. First of all, what I want to do is move on and talk a little bit about how you can go about benchmarking a system to find out what type of GPU you need. So in order to do this, what I'm going to do is share with you a little video. So here's the video, and I'm going to hit the play button and unmute myself. You can see here in this video, we've got a couple of things moving in here. We've got a video that's moving. We're going to have some applications, and we've got something called GPU Profiler. Okay, so GPU Profiler is a free tool written by an NVIDIA person, and it's really, really useful when you're doing POCs, either on the physical workstation that you're moving from, or if you're going to some sizing POC performance testing type of scenarios, then GPU Profiler running in a virtual desktop is a really good way of finding out what the GPU is doing and how much it's helping you. Sorry, it went on mute for some reason again. So as we move on different applications here, we'll see that that frame buffer moves. Okay, so you can see that the frame buffer has actually gone up to maybe 50% of the allocated frame buffer we gave this person with a profile, and it's just a standard WebGL application here. If we open another WebGL application, for instance, you'll actually see in here that the frame buffer goes up even higher. So it's not just about knowing what applications are used on a desktop, but it's also about which applications are used concurrently within a virtual desktop. As you can see, if you move it up to full screen, you can see what happens with the encoder and decoder there. You can see it's actually holding even more data in memory, and that frame buffer is going pretty high now for this 2 GB profile that this particular user has for frame buffer. So also, if we take an application, say for instance, more of a desktop type of graphics application, in this case, we're going to use a Siemens Team Center viewer within here, and we're going to launch a model, a data model of a bicycle. You can see there, our GPU profiler load is now going right up. So you look at the GPU's frame buffer there, we're up to about 90% there. And at that sort of level, you're going to start seeing some performance degradation. You're going to get drop frames, that sort of thing. Because the moment the GPU's frame buffer goes up that high, it has to start swapping stuff out to memory, okay, into shared GPU memory. So you are going to have a performance impact with that. You can see once that application is closed down, that frame buffer goes right down again. Now, as well as doing the sort of live stuff, what we can do is we can actually hit stop on this button here if we've got all the data we want, and we generally recommend a few hours you capture this for, and then you can just save that off to a file for future reference. You can even send that GPU trace to us at NVIDIA. We can help you interpret what type of GPU and frame buffer you need. You can go in here for later analysis and turn off certain things. So in this case, we're just looking at the encoder and decoder. And when that's being used, we look at CPU and RAM as well, and we can obviously look at frame buffer of the GPU and the GPU itself. We can also use the V and U buttons within here. So if we hit the V button, that'll actually give us exactly how much is working, is in use at any given time. So you can actually sample this more. You can even drag and drop in here so that you can actually use a specific segment as well. This is super useful if you've got like a day's worth of data here and you just want to go in on a certain component. So we're going to go back to my screen now. Hopefully you can see the screen. Can you just verify that you can see that screen, Mohammed?
Yeah, I can. It's up for me.
Awesome. So I'm just going to show you one other thing here. So that was a video. This is a real live demonstration. Okay, so this is my own VM that's running at home here. I'm running a couple of things. Again, I'm running GPU profiler within here. So let's start off that GPU profiler. I can see at the moment the GPU isn't doing a great deal. So let's turn CPU and RAM off. We're not really that concerned about that. But the moment that we actually start running a video, we're going to see some things happening. So let's launch that video. Now, at the moment, we're using some of the standard settings. So we're using H.264 for the entire screen. So we're using the video codec. Okay? We're using medium visual quality, and we're using 30 frames per second. Now, this is a 60 frames per second video. So you can see here, it's actually maxing out the protocol at 30 frames per second because we told it that's what we want to do, right? We've told it only to use 30 frames per second. You'll also notice that there's a line here. You can't see that great here. Let's just move it down to encode and decode. You can see that decode is being done by the GPU as well, which is it's creating better performance. You can see for this codec, if you look at stats for nerds here, you can see it's using VP9, and the GPU I'm using, which is an RTX 8000, is capable of decoding VP9. So we're using the GPU there. The yellow line is what's being used by the HDX protocol. So we're actually doing that in memory as well. So let's make some changes and see what happens. So first of all, let's use Remote Display Analyzer, which is another nifty little tool I definitely recommend, and move that up on the fly to 60 frames a second, okay, and see what happens. So the first thing you can see happens is we're now getting close to 60 frames per second from this video. Okay, so this is great. We've now doubled the amount of frames just by changing that setting. Obviously, this is just for this moment. If you want to change it for good, then you need to set up an HDX policy in Studio for that. But you can also see what it's done is it's increased the load on the encoder for HDX as well. If you imagine in an environment where you're sharing that GPU, that's going to affect other users potentially if there's a lot of encoding going on too. So how can we make that a little bit lower so that it's not going to impact other users potentially? Well, another way of doing that is to move from entire full screen down to just actively changing regions. So as Mohammed said, it's only going to now encode H.264 for actively changing regions. So this actively changing region here. Everything else is now done using bitmaps. Okay. So you can see there that the use of the encoder has gone down. So we're not using it so heavily as we were before. And another thing you'll also notice, it might have been too quick for you to notice, but these fonts have cleared up really nicely. I'll just go back there and do that again. We'll go for the entire full screen and you'll see here, look at the fonts. They're slightly fuzzy. And that's because the default is actively changing regions. Okay, sorry, the default is chroma subsampling, which is YUV420. So what that actually means is we send less color information down to the endpoint to make it quicker, assuming that the human eye isn't really going to notice the difference. Well, reality is a designer, an engineer probably is going to, a graphics artist, they are going to notice the difference in colors. Okay. If you're a bank trader and you've got a lot of things like Bloomberg and Reuters up on your screen, and there's lots of stock going up and down, then you've got a lot of this kind of black or blue writing on red backgrounds, and you can really see the fuzzy fonts in there. If we notice, I'll change this back again now to actively changing regions, and you'll see straight away, look at where it says the quick brown fox, okay? And when I change it, you'll notice straight away that it actually gets a lot more clear there, okay? And this is now sending it down using proper bitmaps rather than using the video codec. If that's still not clear to you, what I can do is just show you a picture that I've upscaled, just to show you how much better that is. That's with the chroma subsampling, with the standard H.264, and that's with the actively changing regions policy. Obviously, you can change this to YUV444 and send all the color information down, but you're going to triple the bandwidth needed to get that color information down there. Far better approach is to use the actively changing regions policy and actually do it a little bit more intelligently. When you can actually see how this works. So you can see this bit is an actively changing region. So if I move this into the foreground for a second, you'll see for a second that it's slightly blurry, but then it will sharpen up. Watch this. Did you see that? Okay, that's now sharpened up because the protocol has decided this part of the screen is now no longer actively changing, and it's sending bitmaps instead. Let's do it once more. Again, the protocol will say, well, if I hadn't finished the video, it will say this is an actively changing region. If we move it back to a text region, you can see there. Okay, so hopefully that's clear over the webinar. Really good demonstration there, I think, of how actively changing regions works and frames per second. So that is that's my demonstration. Just want to finish off just by talking a little bit here about key considerations. We're just going to spend a few minutes talking about which GPU and which license in a few seconds. I really appreciate that we're going to go slightly over at this time. Hopefully you're getting some useful information out of this though, guys. So please hang on if you can, and we'll talk a little bit more about GPUs in a few seconds. So first thing, do a POC before you decide. Don't make a paper-based calculation on how much density you can get without actually doing some proper sampling. Use real endpoints, use real workloads and real users. So get the users to behave exactly as they would do on a daily basis. Capture all of that information using GPU Profiler, maybe for 3 or 4 hours. Just see what the users are doing, and then make your assessment there on how many CPUs you need, how many GPU profile, or size of GPU profile you need as well. Think about future requirements. So, you know, who would have known that we'd all start suddenly using webcams 2 years ago? Well, you know, it could have been that people just use standard video conferencing before that. Things have changed. People are wanting to use more and more video content as time goes by. So try to factor that into your equation. Another thing I see a lot of people using is benchmarking that's designed for gaming. Now, be slightly careful here because we do have these artificial limits for frame rates in here, just to avoid any kind of noisy neighbor syndromes and have a good share for all users of the GPU. If you put a gaming benchmark in here and say, well, hang on, I was using my RTX 3060 at home and I was running 120 frames per second with this benchmark. I come into the office and it's now 45. That's rubbish. Well, the reality is people aren't using Call of Duty in the office, right? They're using spreadsheets, web pages, that kind of thing. It's not really a good like-for-like scenario. Also, be careful of benchmarks like logging VSI, which don't tend to be that graphical in nature and to some extent don't replicate what users are doing fully in today's desktop. And also, finally, just look at the whole graphics pipeline, guys. Think about the GPU right up through hardware, right up through the applications and GPU profiles and densities, right through the protocols down to the endpoint. Think of that as in a holistic way to get your best performance in there. Now, a few things about which GPU. I'm going to go through this really, really quickly. Essentially, we've got a whole lineup of GPUs that you can use. And think of GPUs a little bit like cars or like vehicles, right? Different vehicles are right for different workloads, okay? You've got vans, you've got tractors, you've got buses, you've got cars, right? And it's exactly the same with our GPU range. If you go up to the top, you've got the A100 and the A30. Now, these are great cards, and they're really good for artificial intelligence, training, high performance computing, that sort of workload. But the A100 and the A30 don't have graphics capabilities in them, okay? So don't assume that you can use these with standard VDI desktops, because you can't. In the car world or the vehicle world, these would be like combine harvesters or a tractor, really good at plowing fields and getting the crops up at the end of the season, but really bad at going down to Tesco and getting your shopping, right? So they're dedicated for that purpose. At the top end of the graphics use case, we've got A40. That's our top end graphics card. That's for really heavy workloads, okay? A lot of number crunching, a lot of rendering, a lot of high-end graphics in there. Down at the other end, we've got the A16. A16 is, if the A40 is a Ferrari or a Porsche, then the A16 is a school bus, okay? The GPUs on the A16 aren't massively powerful compared to the A40, but there are 4 of them, and that GPU has got 64 gig of RAM, so you can get lots and lots of kids on that school bus and get them very safely down to school. It's not going to be the fastest bus vehicle out there, but the A16 is going to give you that extra density you need. As I say, 4 GPUs, very low contention because we have those extra GPUs. It's not a single GPU card like an A40. Up to 64 users we can put on there. And in between, there's a whole number of other GPUs as well. So the little sister, if you like, of the A40 is the A10. So it's like an A40, which has got 48 gig of RAM. The A10's got 24 gig. So it's kind of like a medium range professional graphics card. Nearly the same amount of cores as an A40. Still a very, very good card if you can get hold of one. Down at the lower end, we have the T4. The T4 was a great card for the last 3 or 4 years, just for office worker and low-end professional graphics. We now have the A2 as well, which is based on one of the GPUs that the A16 has got in it. So the A16 has got 4 GPUs. The A2 is one of those GPUs in a single form factor. You see here, here's the size of an A2. Now, when would you use one of these cards? So here's an A2 and here's an A16. Okay, you can see they're completely different size cards. Okay, this is a 2-slot card, this is a 1-slot card, but this one has got 4 GPUs on it. This one's got 1 of the same GPUs as this has. Okay, so in order to get the same power that this guy has got, 64 gig of RAM and 4 GPUs, you'd have to have 4 of these. So you'd end up taking 4 PCIe slots. This only does it in 2 PCIe slots. So this is also going to be cheaper than 4 of these. Okay, so it's going to take up less room. It's about the same power if you think of 4 of these versus 1 of those, but always go for the A16 where you can, unless you're in space constrained environments. So your server chassis doesn't have space for a double width card. maybe power constrained environments as well. This is really a card that's aimed around edge applications, edge inference applications, okay, the A2. The T4 is roughly equivalent to the A4, a little bit more powerful, a few more cores, previous generation. That's another one. So really, I think the best way of thinking about all of this is if you're in an office worker or low-end professional graphics space, you're going to want to use the A16. That's going to be your best card. It's relatively low cost compared to the A40s of this world. Go for the A16. If you want a default card for medium and high Pro Viz users, go for the A40 card, which is exactly the same form factor and look and feel as the A16. In fact, I've got one. It back here, but I've actually got one. There you go. There's an A40. You can tell it's an A40 because it's actually got some outputs on it, which the A16 doesn't have. So that's the GPU lineup. One more slide I just want to show you though is about licensing. So with NVIDIA GPU, you have to have a license to activate full performance, and really which license you go for will just depend on what type of application you have. So if you're in a virtual apps world, so as it used to be called a Zen app environment, then the right license for you is virtual apps, and that's done based on concurrent users. Virtual PC, again, that is for full VDI desktops running Windows 10, but only up to 45 frames per second and only up to 2 gig of frame buffer. So that's perfectly matched with a standard office worker type of workload. If you've got anyone who actually does graphics for a living, okay, so they're a designer, an engineer, a graphics artist, something like that, then they'll be needing the NVIDIA RTX Virtual Workstation license, which goes above that 2 gigabyte boundary up to the maximum of the card. It gives you 60 frames per second. It gives you access to protocols like CUDA that the virtual apps license doesn't give you, and that's going to be the license you use. So, broadly speaking, if someone does graphics for a living, they're probably going to need Virtual Workstation. If they're a standard Office user with standard Office applications, then Virtual PC, or if they're on a Zen app environment, Virtual Apps environment, Virtual Apps, or NVIDIA Virtual Apps. Okay. Again, there's a link down the bottom there. They are all in the webinar deck as well. It's called Useful Links PDF. So download that from here if you want these links for the future. And really, I just want to finish off just by saying this isn't just about on-prem, right? So you can put these GPUs into your data center and do hybrid cloud with Citrix Cloud. So your control plane in the cloud, you can either have your NVIDIA license server in the cloud if you want to now, and you can have this on-prem. But there are solutions out there for fractional GPU or GPU, virtual GPU, if you like, that are coming out in the public cloud as well. So Azure has got a new tech preview based on the A10. So they've actually, all the A10s went to Azure, it would seem, because they put a load of A10s into their cloud now. And you can get fractional GPU, various sizes of A10 as well within there. And that's just going to go forward and forward as time goes by. As I say, it's in tech preview right now. So that's me. I've been through quite a lot of stuff, and we've been joined by the man himself, Mohammed, to talk about the HDX protocol. We've talked about how do you do GPU-enabled virtual desktops. We've talked about how to do sizing and troubleshooting and looking at the protocols with GPU Profiler as well. And we've talked about some of the things you might want to do with POCs. We've talked about licensing, and I've shown you a whole bunch of GPUs as well, and which is the right one for your individual workload. So thanks very much for your time, and back to you, Rubel.
Thank you so much, Lee. It was lovely hearing you guys out, and Mohammed, you as well. It was lovely to get those insights. All right, for you audience, as I promised, every 10th attendee on this webinar will receive an email where you can just give us your address so we can ship you the device. If you're the lucky 10th, you'll know in the next 24 hours. Next slide, please. And thank you so much for that. I know we've overshot by time, but I see our audience is still active, still there. So let me take a couple of questions if we can. So there are quite a few questions. I'm afraid we won't be able to take all. And we will answer those over emails, or there was an idea of putting together a blog post perhaps to answer some of those questions. But Mohammed, one question to you. There is a question around the Citrix HDX performance versus some of the competitors in the market? Do you have any insights or any data that you can provide in terms of how does our performance is better over competitors?
I don't have any data I can share with you today on the call, but I'm happy to take it offline and talk privately about some of the results we've seen. What I can say is that, putting the figures aside, where we were once behind, we are now well ahead. And I think I'll leave it at that.
Yeah, I can actually talk a little bit about it. I won't tread on anyone here. I just want to point out that obviously I'm ex-Citrix, so I'm sort of a little bit biased there. But I've always thought that you've got other vendors out there, and Citrix has always really led the way here. Now, because Citrix has been focused in other areas over the last couple of years, this has given some of the other competitors a little bit of chance to sort of come up to parity. But guess what? You've got Mohammed, right? And Mohammed has seen that, and he's now leapt ahead with the next version of HDX to maintain leadership there. So,
and the great team behind me as well. It's not just
absolutely.
me. Happy to take the credit, but no, not just me. But yeah, we, as Lee said, we had spent a lot of time optimizing for bandwidth and scalability for the 80% use case, we call it, where we are trying to get as many users onto one box as possible, perhaps without a GPU. And we kind of took our eye off the ball a bit, but we have since focused back on that high-end use case. We managed to reproduce what our customers and partners had been seeing. We managed to reproduce that internally with the help of NVIDIA, providing us with some of the GPUs Lee mentioned. And yes, we, if you read the blog, it kind of gives you an indication of our thought process here and what we did. And we were really amazed by the results. We never expected to leapfrog the competition, but we have done. And we're really happy about that.
Awesome. Thank you so much. I see a couple of hands going up. Let's see if we can get some people to interact a bit. So there's Shannon. I've just allowed you to unmute yourself. If you have any questions, please go for it. Shannon Brown from Samsung.
I'm sorry I didn't have any question, but thanks for the presentation.
Absolutely, no worries. Thanks a lot. All right, so there's one more. I'm seeing, are the new 8K HDR monitors being supported in Citrix DAS with NVIDIA GPU?
So that's a really good question, and I can tell you that we are working on HDR support as we speak. It's a project which I'm involved in, and as far as 8K goes, we haven't actually tested 8K internally yet, but we have tested resolutions up to 4K, and we're seeing really good performance here. I can't share with you a release timeline yet, but what I can say, it should be hopefully within the next release or two, but I can't commit on which one yet.
Sure, no worries. I think there are lots of questions flowing in. I see about 25 of those. I'm afraid we don't have too much time for that. So what we do is, ladies and gentlemen, we'll make sure we answer those questions over emails. And for Lee, Mohammed, that just means some more work for you. So I'm going to be sending over those questions to you if you don't mind. Please sending me back and the answers, and I'll send those over to the audience. With that, thank you so much, Lee. Thank you, Mohammed. It was lovely having you guys speak on our webinar. And ladies and gentlemen, thank you so much for taking the time today to view our webinar. As I promised, you'll receive an email from us with the recording, and those of you who won the gift will receive a special email as well. With that, let's wrap this up. Thank you so much for your time today. Have a good day.
Thanks, guys.
Thank you, everyone. Bye.
Cheers. Bye.
Bye-bye.